Welcome back, everyone, to Energy Visionary. I'm proud to present Rami Belson from Energex Inc. Incorporated. His company produces and supplies smart thermostats for hospitality and commercial spaces. And today we're going to find out the benefits and how it can help you lower energy costs. So welcome to Energy Visionary, Rami.
Thank you very much for having me on, and happy to be here. Thank you everyone for being here. My name is Rami and I run Energex out of Vancouver, BC. We're a developer of smart connected thermostats. Our thermostats, unlike the majority of thermostats out there in the market today, are connected to our AI driver. That means we collect and gather information from multiple data sources in order to produce better energy performance and energy savings out of your climate and comfort control system. Ideally, we have developed the systems for the thermostats for the hospitality industry, where there are several criteria in place that are required. For example, a nicer, better looking industrial design, something that's a little more comfortable in the eyes, that help shape the space into a little more meaningful and conscientious. We also provide for simpler, easier control and navigation. We also have the flexibility of making them in white, black, and coming up rose gold in order to provide better creative design options. But most importantly is what drives the thermostat from behind. Each thermostat is connected to our AI driver, which continuously monitors the state of the room, the space, and the environment around us. The more data we gather, the more we can understand about the space, the number of fan time hours, the number of filter hours, the average temperature vis-a-vis the outside temperature. As these points gather in our AI database, we are able to make significant energy decisions in terms of where to set back, what is the best temperature to be in, during which time. All of that, as we collect it, gives us around a 30 to 40% return on investment when multiple sensors are combined into the thermostat. So the thermostat is smart enough not just to talk to the AI, but it also talks to a series of sensors around it, such as the window sensor or door sensor above me, or the occupancy sensor right above on our ceiling here. Both provide occupancy and door status information to the thermostat, which in turn takes that and turns it into actionable energy information. For example, if the room is unoccupied, invisible to the PIR occupancy sensor, the thermostat will set back the temperature into the most energy efficient set point, not just based on vacancy, but where is the outdoor air data is, how long the space has been vacant, the relative humidity and the general sense of somatic comfort in the space. All of that is gathered, and we are able to improve comfort while delivering substantial energy savings, generally anywhere between 8 to 12 months return on investment. It's most visible if we take a look at what the AI, what our driver, what a dashboard looks like on the other side. So for the thermostat to operate, we just need a simple Wi-Fi network. So unlike complicated, expensive DDC or BAS or BACnet type automation system that requires structured cabling, data, etc., we are able to interface into most Wi-Fi, which is networks which are ubiquitous anywhere, whether you're in your own apartment or in a student housing or in a hotel. There's a Wi-Fi network to energize the thermostat, and from that point on, we'll go to the next level of where all the heavy lifting is happening, and that is in our AI engine. So we're just going to log out and go into the main login page. This is what the login page looks like, and most users will face as their first step. We have permission from our customer, the Hilton Garden Vacation on Paradise in Las Vegas, to show the 6th floor data at any given time. So we're going to navigate into that building. And right now we have a live picture of everything in the 6th floor in that Hilton Grand Vacation right down in the lovely strip in Las Vegas. The first key point that we are paying attention to is right on top here, is the outside air temperature. That allows our AI engine to understand of where to go to when rooms are vacant during different times, during nighttime, during daytime, long-term vacancy, etc. It also gives the operator a full view of which rooms are occupied, shown in here under yes, and the rooms that are occupied will get a special treatment. For example, if a room is occupied, there will be no knocks on the door. So it allows the housekeeping resources to navigate more efficiently through the building. We can also control the temperature, and more importantly, we can actually drill down to each room and pay attention if room gets too hot, too cold, if it takes it too long to heat or too long to cool. All of these points can be gathered into our driver and generate alerts and a whole system of supervision of these devices that allows you to maximize every dollar that you are spending in the space on energy. For example, here we're looking at the last 24 hours of this particular room, room 607 on the 6th floor at Hilton Grand Vacation, and we can see that we had limited occupancy represented by orange bars representing occupancy minutes each hour. We can also see that as soon as the room became occupied, represented by orange line, we can see that the air conditioner has been turned on for that guest. Up to that point, there has been no orange lines or blue lines. That means when there's no occupancy in the room, we are denying the use of energy. And all of that is based on the outside air temperature as indicated by the green line. We can also drill a little further into and see better history or deeper history and take a look at the historical data in this room. In this particular case, we're looking at 4 days with limited occupancy. And one of the first things to jump at us is we can see how the blue line representing air conditioning are only represented when their occupancy is in the room represented by orange lines. So you can see the denial of energy from rooms that are vacant. And they are vacant, in this particular case, the room has been vacant for 50% of the time. So that gives us almost 50% denial of energy during, or at least 50% opportunity to deny energy and play with the temperature. Now, the next thing you'll note in this particular chart is where there is no occupancy, represented by the lack of orange lines, the indoor air temperature is raised above the set point. That means if we don't see occupancy, we raise the temperature in the room by denying air conditioning from running. And if we're to gather this and extrapolate it back, we'll probably be seeing about a 40% reduction in energy here, Aaron. Now, the next step for the software, as an asset operator or a building operator, or if just a person who owns this particular piece of HVAC, we can also log in deeper and set and define a series of alerts that can be sent in email or SMS or any choice to read a directory of functionaries within an organization that need that information. That means if the room gets too cold, too hot, if it takes it too long to heat or too long to cool, we can pay attention to the process of heating. We might detect that there's an issue with the compressor or issue with the heating element. As we gather those data points, we are able to understand and translate that back into actionable workflow data to the operators of the building. So we're transcending beyond just energy management or energy savings, looking to the operational benefit of holistically the operation of the HVAC into such coherent point where they're actually complementing each other and helping each other learn from each other in order to benefit for better energy savings and better building management and control.
I'd like to jump in for a couple points. So kudos to you for taking a simple device like a thermostat and turning it into a innovative control system for a hotel or a property owner. So we work in commercial space, a lot of high-rise towers, and we designed the control system, and it's a very expensive system to run all the HVAC, and it's fairly complex. So kudos to you for simplifying that for the property owner. And when we do energy audits, it is difficult to do them in a hotel because it's mainly just based on occupancy, and there's not a lot to a hotel room. They usually have a wall unit, fan coil that can do heating or cooling. And often the problem is it just runs all the time, maintaining that temperature in the room. And if a guest crank the heat, air conditioning on, crank temperature down, it'll continue to waste energy. So Energex has an amazing simplification of that process where, you know, it gives power back to the property owner to visibly see what's going on in these rooms without intruding on a guest. So really powerful tool. I'm glad you got to share that with us today.
I wanted to point out, Aaron, also that part of the design intent of the thermostat, I mean, as the population ages, hardest for us to see. It's harder for us to see our digits. A lot of the time, we do cater to retirement homes and people with long-term care. So part of the design intent was to make the digit as large as possible in order to make all old folks control and navigate it easy. We also added the blue and the red that actually helps them understand that they're actually navigating to intensity. So that actually the simplification part was also to make it useful and beneficial to a lot of our clientele that are in retirement home, or general clientele that are aging right now and are not looking for something with 10, 20 buttons to operate. They want something really simple. And let the AI do everything else as far as managing and doing all that.
Yeah, that's a really good point. How simple the device is. You know, everyone's used to just rotating the dial. And, you know, I've been in hotel rooms with the Energex thermostat, and I was impressed. Like you said, visually it looks great, and you can tell you're turning up the heat. It turns red. You turn it to cool, it turns blue. So really good design. I really did appreciate that when I did stay in a hotel room with one. But again, I want to ask a few questions. So COVID has wreaked havoc on the supply chain. I just want to ask, for you right now, is this affecting your supply, and where is it manufactured?
Oddly enough, Aaron, that's a good question. Our problem started around November 2019, where our factory in China, in Beijing, began to take time to produce orders and turn around custom designs, fabrications. Everything started taking slow. So I think everything kind of came to a grinding halt around mid-March 2020. We actually began to feel it in 2019, around November, when the virus began spreading in China, where our sources of, and I think one of the things that we noticed first is China was one of the first countries to come out of it. So the sense was that yes, it's not that great, but there is a way out for people who are looking for it. That's actually brought up another point that you mentioned. We realized right away there's going to be some requirements with respect to the environmental control of space that will take into consideration the upcoming code references and the code requirements as far as ventilation, air, better attention to filter use, etc. So we figured that a lot of this data can be applied in a way that's going to actually be complementary to the new upcoming standards as far as requirements for better health, better circulation, and that's coming on two levels. There is the push from the users, from the health, from the traveling public. They want to feel safe, especially outside their home, and as far as building codes requiring better transportation of air, better replacement, better more fresh air, more circulated.
Yeah, absolutely. It is already a very powerful driving factor in the way we design properties, and the way that property owners are investing in energy efficiency. I think this one is a no-brainer for an energy conservation measure to not only make the space look nicer, but also more energy efficient and not wasting that power or energy when nobody's in the room.
Right. Think about the advantages that the users, the owner of the asset or the owner of a bank thermostat, if they had an infection in specific part of the building, they can actually pinpoint some of the fans and actually increase them or decrease them in order to create better circulation or less circulation in order to contain a situation that they're facing. These are literally things that we are discovering that are benefits that are permeating both sides.
It's a really good point. It's something, like I said, it's a simple idea, and once you drill into it, it has so many benefits to the client, and that's why I'm proud to have you on the platform today.
Oh, thank you.
So maybe we could get into some case studies and look at some of the numbers and results that your clients have been seeing, if you have a few to share.
So we've been fortunate enough to work with Export Canada recently, who were looking for a sort of Canadian success story, but not in Canada and not in the hospitality field. They wanted something more along the residential, commercial type of space, and they wanted something more U.S. centric. It happened that we have worked on a property called Mountain Lodge in Telluride, Colorado, which is sort of an Aspen kind of beautiful settings, very wild, sort of like our Whistler. They had a series of challenges in this particular building. Number one, it's owned by multiple owners, and as such, it was harder for them to measure the energy because there's a central plant delivering hot water to all of those different apartments. Central plant is shared by a group of owner who's wasting all this money. Then they drilled a little further, and of course they saw that who's wasting the energy are the guests spending 6 and 7 and 8 and 9 hours on the slope while not bothering to take the setback. The temperature while they are on the slope gets even worse. You could be checking out and leaving that unit without heat, without the next guest for another week, a week and a half, set up to 80 or 90 degrees Fahrenheit, and that contributes even more energy demands on that particular building. As the bills are shared by a limited number of owners, it became a problem, and they really wanted to drill where that problem was coming from. So first challenges, because of the vintage of the building, one of the first challenges that they had, that there was a single pair of wire for thermostat control. A lot of engineers have been specifying it all through the 70s, 80s, and 90s. So the first challenge was how to take a single wire thermostat and convert it into a fully functional communicating circuit. So we've added a diode kit that actually allowed us to go from 2 wire to 3 wires, and allows us to get fully powered thermostat with a C wire on top of a single pair. Engineers will understand it. But that was the first challenge that the building didn't realize that they could do, was to migrate from a single wire into a multiple wire environment that allows them now connectivity, energy management, better comfort, etc. So that was the first step, is to sort of introduce them into how good control should work. The next step was, of course, to pay attention to all those vacancy that we saw in there. I mean, they're just vacant for many, many hours at a time. Third was to make sure that we have a variety of scenarios. So if somebody's just gone for 3 or 4 hours to ski, then we'll have one scenario of ski, the setback. But if a unit has been vacant for 2 or 3 and 4 and 5 days, then we'll have another scenario of setback, and all that setback can further enhance based on what we know the set point are, the occupancy, the temperature outside, and based on that, we can collate that data and actually present the owners with a case study. So okay, I'm happy and fortunate enough to have that case study of Mountain View, which I will circulate to you, a Mountain Lodge, presented in almost every Canadian embassy around the world as part of the Canadian technology feature.
Excellent. Yeah, I'll definitely add the case study download to the profile down below.
This is one of the crown jewels of our building. This is the Telesky in Canada, in Calgary. It's one of the smartest buildings in Canada, both in and out. I guess it's down the road from you, no, Aaron? You had a chance to see it?
I actually saw it yesterday.
Is it shining nice at night as they said it is?
Yeah, I was looking at it yesterday, actually, on the drive into the office.
Really, in technology, we definitely are proud of it. So we work in progress, because the guests, the tenants, the residents are now issued an app on their phone, and they can pay their rent, they can control their thermostat, they can do everything from out there. So there's some other some other cool factors that are added as bundles, part of the TELUS package to their guests and residents.
Oh, that's really cool. We did have a developer ask us about that thermostat control on smartphone. So that would be something that you could provide.
Oh yeah, I mean they are actually right now we're looking to do more and more. We are doing quite a few APIs with companies who specialize in bundling those technologies to residential new towers. So for example, if it's a residential tower, they'll be looking to pay their rent or get some kind of maintenance request or control their temperature or set it back or get reports of their energy history. Everything else that kind of allows them to feel interacted with the space that they live in.
For an energy audit, once an energy audit's completed, maybe walk through the process of what would be required for an owner to go through if they had an existing old thermostat on the wall, no occupancy sensors, and a wall heating and cooling unit fan coil on the wall. So what would be the process for them to do the upgrade for your Energex thermostat?
Good point, Aaron. So I think there's a variety of pain points. Some of that is aging thermostats that are simply unusable or stuck. In some buildings, you have mechanical thermostats that are locked inside plastic cages that are really making no sense. I mean, this one, for example, can be locked to the cloud, and there'll be a lock sign here in 3 seconds, and we can lock it to. We have the tools to work much smarter today. But I think that there are different drivers to why people need new thermostats. Number one is of course the energy. Right now, your HVAC equipment takes almost 60% energy within the space that you live in. 60% is a lot, and definitely some adjustments can be made based on improvement to the efficiency of the equipment, and just as importantly, improvement to the behavior around of how we perceive comfort and where should we be on different times of day. At the times we are in the space, and the time we are in the space but sleeping, or in the time that we're in the space with the window open. So all this data can allow us to gather it in a way that we can instantly turn that into actionable data to say, hey, you're in your room, it's 16 degrees outside, we're going to do this for you. You're going to save 10%, and you're not going to even feel it.
Definitely the goal for energy efficiency is shutting off things when they don't need to be on without affecting the user's comfort. So this is definitely accomplishing that goal.
Exactly. I mean, we realize that there is an endpoint. There's a point where we're not going to squeeze any more energy from that space. But once we reach that point, the return on investment, both financial to the owner, both in terms of environmental benefits, and even on our own personal satisfaction, are amazing. To understand that you've actually reached to the cusp of a point where you can actually maximize the energy and say, this building is as efficient that it can be made, thanks in part to our technology.
Excellent. So as far as the installation goes, if a property owner were to purchase direct, could their maintenance or engineering staff complete the swap from the old thermostat to your system?
So if we're talking about the standard package terminal, 24-volt, Honeywell type thermostat, the answer is yes, Aaron. There are 6 or 7 wires at the back of the thermostat. There are also some inputs for occupancy sensors and different sensors. But the 5-6 wires are split like any system in the same color coding as the CTI, Common Thermostat Interface. And that means yellow means mellow, means cool, white means heat, black means power, red means heat. Alive, and same color coding as so it will be a direct swap. More so, we've actually designed the footprint of the thermostat a little wider in order to be able to cover elements of dirt from a previous thermostat without having to touch up or paint the wall or use nasty looking plates that some other thermostats are bundled, which is not a solution. We want to make sure that the profile is as clean and cover previous damage from previous thermostats. So that's
that's a really good point, because sometimes you do remove it and you try to put on, you know, a round one and it might show the gap. So now you have to replace the wallpaper or repaint. So
or the previous stains from the previous thermostat. So we want to make us flush, especially on a retrofit situation.
yeah.
You don't want to paint the whole wall just because you decided to upgrade the thermostat.
Yeah, as much as we do the mechanical and the electrical engineering design, I know our architect friends will really appreciate how nice this thermostat looks when we have to put them in various locations.
It doesn't matter, both the color choices, depending on the space, they're really complementary and they really add a lot compared to, you know, the majority of what we know to be out there.
Excellent. So does Energex offer any energy efficiency calculator online?
We do, Aaron. That's a good point. Again, one of the things that we like is not just calculate the denied energy, but the amount of energy that our technology is prevented from discharging into the space due to the variety of steps, but actually create that and convert that into something very actionable. And you have a chart saying, hey, the last 24 hours, your savings are X number of dollars or X number of trees or X number of ROI your investment. So we can actually create a visual representation of the intelligence of the decision of picking our thermostats.
Excellent. Yeah, and for anyone who hasn't seen it yet, I would highly recommend you go visit Energex Thermostat. We'll put the actual link in the description down below. And it's a very nice looking website, and there is the calculator tool on there. And feel free to reach out directly to Rami and his sales team to get your Energex thermostat and increase your energy efficiency for your hospitality or commercial space.
Ask us about how you get one for free also. We'll be happy to tell you.
All right. So for Energy Visionary Network and Community, Rami has offered to give away a thermostat if you complete a skill testing questionnaire based on this presentation. So submit your information down below and return the questions for your chance to win a thermostat.
Sounds like applying to me.
Thanks again, Rami, for presenting on Energex thermostats. I think it will be a huge benefit to our clients and our network to take a look at this product to lower their energy costs for their hospitality, hotels, commercial space, and really give a simple view of who's in a particular room and how much energy are they using if they're actually in that particular suite or room. So really powerful tool, a simple upgrade, a low cost energy conservation measure. So I appreciate you joining us today on Energy Visionary Network.
You bet. Thank you, Aaron. Take care.
Bye.